Page 102, I'm going to skip down and graph my scatter plot. All right, so my X was my bounce and my Y was my height. Bounce and height, we counted by a half. 3, 4, 5. 1, 4, 2, 2.8, 3, 2, 4, 1.4. Okay, did you kind of get that? It looks a little bit linear, but it actually is an exponential function. So it actually, like if I had just drawn a linear graph, if I connected these 2 points, I would come straight down and I would miss all those other points, right? If I used like a straight edge, like a computer stick. Right? So the line of best fit. This giant Okay, so if I just did a line of best fit, see how those 2 points, see how you can actually see the curve. If I tried to connect these with a straight line, see how I would miss all those other points. So sometimes it's hard to tell the difference between linear and exponential, but this really is, it's kind of curving like this. So based on your scatter plot, what type of function could be used to represent the data? It's an exponential because it's a curve. Justify your reasoning. We don't have a lot to go on besides just comparing it to linear and quadratic at this point. All right, so we did okay on that. So situation 2. We won't skip this because a lot of you actually do work for an hourly rate, right? Do a lot of you work at somewhere in the valley and you get paid by the hour? So this says 4 different retail workers each received different paychecks this week. Kayla worked 4.5 hours. She got paid $57.38. Sean worked 20 hours. He got this much. Carly worked 32, and Tony worked 39. What is each person's hourly wage? We're not graphing it, but if you worked 4.5 hours and you made $57.38, how could you figure out your hourly wage? What would you do to figure it out? Do you guys ever check if your paycheck is correct? Like, I know I worked 20 hours. My paycheck should be, right? What do you make? $13 an hour, $15 an hour at Cranmore? I don't know. So you do your 20 times 13 or 15. So how am I going to go backwards? I know what my check was. I know how many hours I worked. What did I make per hour? What do I do? Rushi, right? Yeah, just divide them. Take your amount and divide by your number of hours. So who needs a calculator at their desk? I have some that are charging. I don't have quite 20, so. You guys have a few calculator? Yes, you're using something? Okay, you have one. Need one. Need one. You get one over as well. You all have one? Okay, who's using their phone? Do you want it? Oh, okay, when we do the graph, you might need one of these calculators. All right, so if I take 57.38 and I divide by 4.5 hours, what did that person make? 57.38 divided by 4.5. 12.75. What's that, Kayla? Kayla made 12.75. Did they all make the same amount per hour? So if I try Sean, if I take 255 and divide by 20, he also made 12.75. So you can check the other two. I checked Sean. Sean made 12.75. So check if Carly and Tony also made 12.75 an hour. And then we're going to think, what type of function should I use to represent this data? So did you try them? Do they make the same? I think I remember that they do make the same, but we did this problem back in September. So 408 divided by 32 and 497.25 divided by 3. Okay, so they all make 12.75 an hour, right? All right, so what type of function is used to represent this data? This is a constant rate of change, right? If I work 2, I do 2 times 12.75. If I work 10, I do 10 times 12.75. What type of function has a constant rate of change? One of the big three. Constant rate of change has a slope, right? It's a line, linear. So the first one was exponential. The second one was linear. What do you think the third one is going to be? The other one of the three, right? So this time, let's see how you do. Can you try to set up your X and Y axis to make sure that all of the data will fit? Don't do this crazy break in the graph where you just start at like 28, right? I'd like you to actually count by like 10s or count by 20s, count by something on the Y-axis that's evenly spaced all the way from 0 that's going to fit the data. See if you can plot that for a couple minutes yourself. And if you do questions, now that I have the equation, what bounce height would you predict for the 8th bounce? Where do I plug in the number 8 into this equation? Right here for X, right? X is the number of bounces. So now you can, if you need to go back to the home screen and clear out what you have, you can hit second quit to get back to the home screen. But you're just going to type this equation in with X being 8. And the rebound ratio of the basketball is this 0.71 number. That's how high it hits each time, like a 70%, 71%. So you're going to type in 5.56 times 0.71 to the 8th. 5.56 times 0.71 to the X. And then what's the rebound ratio? 0.71 about. What'd someone get when they typed that in? 5.56 times 0.71 to the 8th. I don't know, I could round. 0.4 about. 0.4 of a foot. So it's less than half a foot by the time it gets to the bottom. All right, so that's where I wanted to leave you with today. But I am going to give you one more thing because I don't want you doing like the note